All right, so a little bit of math enrichment here, the idea behind. So if I want to find the average temperature of n temperatures, I would add them up and divide by n. So the delta x, we know the definition is b minus a over n. So if I solve for n, that's b minus a over delta x. So if I take this n and the average value, replace it with b minus a over delta x, multiply by the reciprocal, I get 1 over b minus a times delta x. So you know, if I add these n things up and take the limit as n goes to infinity, that's an integral. So what I get for the average value, so temperature average value, is 1 over b minus a. The limit as n goes to infinity of this sum is the integral of those temperatures, times dx. So the average value is an average y value. So if I just think about like drawing the temperatures, so if I was starting from here and going up to here, A to B, so the average value is the y value, the average temperature hit over a range between A and B. All right, let's go and do one. Here we have an average temperature. So let's go and find for the first half hour, and this is given in minutes. So the average temperature, T sub average, will be 1 over B minus A. So I'm going to use 0 to 30 minutes. So 1 over 30, 0 to 30. And then I'm going to take the integral of this function. So let's be careful with the details. You know that the integral of 20 is 20t. I'm going to carry along this 75. Let's make my t, there we go, plus 75. Taking the antiderivative of e to the negative 3t, I'll get a negative 1/3 e to the negative 3t. And then I'm going to be evaluating it between 0 and 30. So I'm going to keep this 1 over 30 outside. And I'm going to plug in 30, so I get 600 minus 75 divided by 3, e to the negative 90. Then I'm going to be subtracting off, plugging in 0, and I have to be careful. Remember, when I plug in 0, it does not give me 0. So I get e to the 0, which is 1, so I get negative 75 divided by 3. All right, so this is 1 over 30. 600 minus 25 e to the negative 90, and then plus another 25. All right, let's try a different problem. So if I want to find the average value of this function on this interval, so the f sub average will be 1 over 1 subtract a negative 1. Be really careful with that, between negative 1 and 1. And here I can see that I need to do a u substitution. So this gives me a 1/2 out on the front. If I do a u equal 3 minus 2x, du is negative 2 dx. So negative 1/2 du is dx. So I get another negative 1/2 out here, 1 over u du. I like to change the limit so I don't have to go back. So if I put negative 1 in here, so I put x equal negative 1, that will give me 3 minus 2 times a negative 1, so 3 plus 2, so that's 5. So this turns into 5. If I put in x equal 1, I get u equals 3 minus 2, which is 1. So I can see there's switch, so let me take the time to switch the limits of integration, get rid of the negative sign. And then I have 1 over u du. So now I do not go back to x's. So I have 1/4 ln of u between 1 and 5. So that gives me 1/4 ln of 5 minus 1/4 ln of 1. I know that ln of 1 is 0. So there, that's the y value that gives me the average value of the function.